So they give you a bunch of stuff here, and then you have to use the properties for each of these subsequent problems. So I'm going to snip in question A.
Yeah.
So question A simplifies to the following. It's you bring this 3 out, so it's 3 integral from 5 to -1 f of x minus the integral from 5 to -1 2, and then the dx goes with both of these. It's almost like it distributes in also.
Okay.
And I'm not sure if you did that or not.
I didn't.
Did not. Okay. Now we go to actually what's given. They give you f of x up here, but the bounds are in the opposite order. So whenever you change the order of the bounds here, like to make this -1 to 5 instead of 5 to -1, you have to negate whatever is there.
Okay. Like opposite.
Right. And this one right here is also a little weird. Like you would not normally, it's supposed to be lower to upper, and it's supposed to be the smaller number to the larger number, or left to right. This is just like instructor being difficult here. But when you switch the order of the bounds, and you should do that, you have to change this sign. So this becomes plus the integral from -1 to 5 to dx.
Okay.
Right. Now you could have done that from the beginning, but we did it here. So now this first part, this part right here, not the -3, the -3 comes down. This first part is -4. That's given. That's this given up here.
Okay.
Okay. On the right here, this you either have to use antiderivatives or make a graph or know the formula. This says from -2 to 1. So from -2, I'm sorry, -2, I'm sorry, -1, I keep misspeaking, -1 to 5, it wants the area under the curve of this function too.
Yeah.
So it's this, so it's this rectangle. So some students, will say, okay, well, it's 2 times 5 minus a -1. Some just say, oh, the base is 6 and the height is 2. Some find the antiderivative. It doesn't really matter. You have to come up with whatever you like there for that. So that's 6, that's 12. This is 12, and total of 24.
Okay. Okay. That makes sense.
Great. B. All right, so let's look at B. Okay, B is the integral from -3 to -1, f of x dx, and you're not given. Okay, so that's why this is odd. So you are given. Let me snip in the part that's relevant here. You are told from the beginning here for this given that from -3 to 5 is 7, and from -1 to 5 is -4. So you can combine these results because there's overlap. It's like saying we don't know what f of x looks like, but we know from -1 to 5, whatever the curve looks like, we don't know what it looks like, but we know that the area here is this is -4, which is on the wrong side of the axis. But we know from -3 to 5, like whenever we include this other area, that whatever it may be, that it's 7. So if you want just this area, if you want this area between them, which is what this problem is asking for, you have to realize that you're just taking the difference between them.
Oh, okay.
So it's this second area is like taking away from it. So again, a little bit of a contrived example, but essentially it's 7 minus a -4, which gives you 11 here.
Okay.
Okay.
That one's easy. It's just you have to think it through.
Yes. And you probably these are easy to just change the numbers, so you should expect almost identical problems, just different numbers.
Okay.
I'm going to retake, although I have no knowledge of that. Okay, next question here. This is more like the first one. You separate, you kind of distribute this dx to both. So it's the integral from -1 to 5, 7 g of x dx minus the integral from -1 to 5, 5 f of x dx. And then if you want, if you're more comfortable, you can move those constants out. So it's 7 integral -1 to 5 g of x dx minus 5 times the integral -1 to 5 f of x dx. And then you go back to your givens. You're given for g of x, you're given on the left here that this is 9 and f of x is -4. So this part is 9, and then you bring the 7 down.
Okay.
And then again, this is -4.
Okay.
So 63 plus 20. So notice that like you always get a number as an answer here, whatever you're.
Yeah, it's not gonna have any like variables or anything in it. Just
No,
needs-
no. All right. Let me know when I can move on to question 2.
Yeah, you're good. I get that.
All right, great. So question 2 is one of the fundamental theorems of calculus. What you're supposed to pay attention to is the fact that this is a function and this is a function, and you're being asked to find the derivative. You're asked to find the derivative of the integral. You don't see this again in this course, but like it's really emphasized hard at this part of the class. And it's kind of a recipe. We could give this more, description if we needed to, but it's essentially a recipe. So normally, and you know this from probably doing a bunch of classes, it's top minus bottom.
Yeah.
Okay, and that's what you're going to do here. But you take whatever the top is and you just plug it in for the variable. So this
Okay.
becomes the tangent of 7 times 5x to the 4th to the 6th power. Okay, but there's more. Okay, but the first thing is you put that in for t, whatever the variable is.
Okay.
Then you multiply by the derivative of this top function, which is 20x cubed. And that represents the top.
What's the
Minus,
antiderivative?
I'm sorry?
What's the antiderivative?
No, you're just plopping it in there. It's not even, there really isn't any calculus here.
No, for the 20x.
Nope, it's off to the side. That's the derivative. Yes.
Wait.
This is the derivative of 5x to the 4th. It goes in here.
Okay.
So like the steps are you take whatever's in the top
Oh,
bound,
okay. I'm
you-
overthinking it.
yeah, you put it in for t, but then you multiply the whole thing by the derivative of this. Minus. So then you do the same thing with the bottom bound. You put that in for the variable. So that's tangent of 7 e to the x to the 6th. Okay. But then you multiply by the derivative of the bottom, which is e to the x.
Okay. Yeah.
And that's it.
Okay. Do they want me to?
No, you're
Oh.
done. Nope. There's nothing you could do. I mean, you could raise 5 to the 6, and like, but the instructor is testing, like, do you know where to put each of these things? Where do you put 5x to the 4th? Where do you put e to the x? And then do you remember to multiply by the derivative?
Yeah. Okay.
And as a reminder, I can always provide you another example if you would like that.
Okay. No, I think that makes sense.
Okay.
Yeah,
So I'm ready to move on to 3.
Okay.
All right, use the graph to determine the area. So that what the instructor's trying to say here is like you can graph this function and then you can find the area under the curve. So to graph it, you have to know what an absolute value looks like.
Mhm.
And this one has a vertex at 1, 0 right there. And then this number out in front, this 2 actually tells you the slope of the line, the slope of the V there.
Okay.
And you may or may not have been told that at some point, but it gives you this shape right here. Okay. And then you draw vertical lines at 2 and -2. So there's a horizontal vertical line there and there. And they're saying just find the area of this triangle and find the area of this triangle. You're not doing any Riemann sums. You're not doing anything like that. You're just literally finding the area of two triangles. So triangle number one on the left here, it's 1/2 base times height. The base is 3. The height is 6. Okay, so that's 9. And then triangle number 2, your base is 1 and your height is 2, so it has an area of 1. So the answer here, the answer to this thing right here is 9 plus 1, which is 10.
Okay.
They're saying like just find the area under the curve by graphing it and then recognizing the geometric shape, which could be a triangle, a trapezoid, rectangle, circle.
Okay.
All right, so let's do number 3B.
3B, that was A.
Okay, so again, you just want to make a graph here. This one, yeah, I can do a good job here of this. So let's make sure I got 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then it goes, the slope is -3. So it looks like this. Down 3, right 1, down 3, right 1, down 3, right 1. Now the problem is it actually crosses right there. So it keeps going. So we can keep drawing if we want.
Okay.
All right,
Wait, what's the point on the x-axis?
4.
4. Okay,
4,
where'd that
0.
sorry.
I'm just graphing the slope. I'm starting with the b value. Like I'm going back as if I'm an algebra 1 student. Like
Okay,
here's the y-intercept, go down. You could set it equal to 0 to find that point.
okay. So when
Yeah.
you're graphing it, you choose the equation. You're not looking at the 6 and the 0.
No, I'm not doing any of that. That's just my like start and stop.
Like they're asking for the area.
Yeah, it is important to know those values, but you just go until you're kind of constrained by them.
Okay.
On the left and the right, they're your boundaries. They're your, if you play sports, they're your, your sidelines, so to speak. Okay. Now what's interesting here is that area above the x-axis is positive and area below the x-axis is negative. But when you're finding the area of triangle 1, you are using 1/2 base times height. Your base is 4 and your height is 12. Okay, so your area is 24. But for triangle 2, use the same formula. You just have to know to negate it. You have to know that because it's below the x-axis, it's considered negative.
Okay.
So the base is 2 and the height is 6. Right. I mean, if you didn't, you can make the height negative, then you got to remember not to negate it. You have to come up with some set of rules here, but in truth, you'll never do this again this way. You'll just use the rules if you haven't already. So the integral this time though is 24 because it's above, but you subtract 6 because it's below.
Okay.
It's above and below.
Okay.
So your answer is 18.
Quick question. How do you
Yes.
know that that little triangle is below the x-axis?
Just where it hits there at 4 and then it keeps going.
Okay.
Like I'm just graphing this thing. I'm not like it, and it hits the x-axis there, and then
okay.
and it just keeps going. Like this is the line. This line of y equals -3x plus 12.
Okay.
And it obviously goes down forever, goes up
The
forever.
line going back up to the x-axis is just like
That's the boundary.
it's
That's
like
just
a line. It's just where it wants you to end for there.
yeah. X equals 6 is there, so we know to stop. Yeah,
Okay,
x equals 0.
That's the area from.
Yeah.
Okay. 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 Next question.
Okay. All right. Number 4. So you have the right equation formula for this.
Yay.
So that's good.
Did something right.
I think there's a lot of value in that. If you don't even know where to start, you're
Okay,
gonna struggle.
not a lot of people did well on this test.
Yeah.
Once again, we have a sub who's teaching us
Oh, that's right. You mentioned that.
and
Yeah.
giving us tests from like the other calculus teacher.
Yeah.
But she teaches the way her tests are. And
Right.
he teaches us from the book.
Yeah.
It's not the same.
Yeah. Well, you're doing the best you can.
Ryan.
I'm sure. So your A and B are here. I think you know that from the work I'm seeing. That looks right. So it's 1 over 1 minus a minus 1, integral minus 1 to 1, and then all this 4x cubed minus 3x squared minus 6x plus 3 dx. Okay. Now, the only integral rule that you need to know to do this problem is x to the n dx. So n is an exponent, and the antiderivative, you add 1 to the exponent and you divide by the new exponent.
Okay.
So like when you look at 4x cubed, the 4 just comes along, okay? But this x cubed, you're going to add 1 to the exponent,
Yeah.
and then you divide by the new exponent.
So it's going to be x to the 4th.
Right, those are going to cancel. Next one here, the 3 just comes down. You add 1 to the exponent, and then you divide by the new exponent.
Okay.
It doesn't always cancel, but in this case, the first two have. The exponent, when it's not written, is 1, as a reminder. So you're going to add 1 to that. That's 2 over 2.
Okay,
Now,
so
this last one, you might say, hey, Matthew, there's no variable there. Well, it kind of is. It's x to the 0.
yeah, it's
So
just 3x.
it's just 3x, and you divide by 1. Okay, well, that doesn't do anything. And then this comes down. It's 1/2 on the outside of all of this, and you're evaluating it from -1 to 1.
Yeah.
Okay, so I would clean this up just a little bit here. You know, the 4's cancel, so it's x to the 4th minus x cubed minus 3x squared plus 3x evaluated from -1 to 1. And it's always top minus bottom, top minus bottom.
Yeah.
Okay, so you put the top number in first, and you want to get comfortable with the idea that 1 to the n is always 1, and -1 to the n is 1 or -1 depending on sign. So like you're putting in 1, like I will do this for you, but as a student, I would rather you evaluate it as you go.
Yeah.
Okay, minus, and then the bottom. Okay, this is -1 to the 4th minus a -1 cubed minus 3 times -1 squared plus 3 times -1. So it's very easy to make a sign error here. The first one's not too bad. It's 1 -1 minus 3 plus 3, which all goes to 0.
Yeah.
So you get 0. Okay, -1/2. So this is 1. -1 cubed is -1, but you have a negative there, so that's +1. This is -3 minus 3. So you get -6 plus 1 -4. So it works out to +2.
Okay. Mm.
When you see this done again, do you feel like you could replicate that on the exam?
Yeah, just a little more practice and then for sure
Great.
getting in like the rhythm of it.
Yes. Okay, so 5, you must show all your work. Okay. So 5A is probably should have come before 4. It's kind of that power rule integral that I've mentioned here a couple of times, where you add 1 to the exponent and you divide by the new exponent.
Yeah.
So here you get 6x cubed over 3 evaluated from -1 to 3. And then you want to simplify. So it's 2x cubed from -1 to 3. It's top minus bottom always.
Mhm.
So it's 2 times 3 cubed minus 2 times -1 cubed. So that's 2754. -1 cubed is -1 times -2 is +2. So you get 56.
Okay. Okay. So it's basically the same thing as last one, just easier and more simple.
Yes.
Okay.
Now B is different.
Okay.
So if you haven't gotten to this part of the course yet, you will be shortly. You're doing more integration, but you only have a finite set of integrals that you know how to do, and you have to start making them look like this. So the one that you know how to do is 1 over x. The antiderivative of this is the natural log of the absolute value of x.
Mhm.
But this doesn't look like that. See how this -2 is there? You want to bring that out. So it's -2 integral 1 to 9, 1 over x dx. So when you do this, you then realize, oh, I can use this rule over here on the right. You could leave it inside there, like the -2 could be here. It's whatever you kind of like when you do this.
Okay.
So it's -2 natural log of the absolute value of x. The natural log of the absolute value of x is this part right here, but then you have to evaluate it from 1 to 9.
Okay.
Again, it's top minus bottom. So it's -2 natural log absolute value of 9 minus -2 natural log absolute value of 1. Natural log of the absolute value of 1 is 0. So it becomes -2 natural log absolute value of 9.
Okay. Okay.
Is C okay? Is C, we'll go through C. All right. So it's really two antiderivatives. The integral of a constant dx is always that constant times x. So in case this one, the antiderivative is x. Okay. But before we do that, you sometimes you have a rewrite step when you're doing these problems. So this is really the integral from 1 plus 4x to the -3.
Okay.
And that helps you to use your power rule, because and we've used this a few times here, you're going to add 1, divide by the new exponent. Doesn't matter whether the exponent is negative, decimal, fraction, whatever, as long as it's not -1, you use this rule on the right.
Okay.
So the antiderivative of 1 is just x, or in other words, the derivative of x is 1. Okay. Here though, you're going to add 1 to the exponent, and then you divide by the new exponent. So if you see that that's -2, that's why it's -2 on the bottom.
Okay.
And we're going to evaluate from 1 to 4. So we should simplify this just a tiny bit here. This is x minus 2. This is really x to the -2. And what I would recommend is writing it as positive exponents. It's just make simplifying it easier.
Yeah.
Okay, from 1 to 4. So now you can put that top number in. It's 4 minus 2 over 4 squared minus 1 minus 2 over 1 squared. Whatever you're subtracting, it's good to put that all in parentheses so you don't accidentally get a sign out of order or out of place here.
Mm-hmm. Yeah.
4 minus 2 over 16, 1/8. And then you can start distributing this in there. So it's -1 plus 2. So that makes 1. That makes 5. 5 over 1 is 40 over 8 minus 1/8. So it looks like it's 39 over 8.
Okay. Sounds good.
All right, moving on to D. Your attempt here to show work is actually quite good in most of these problems. Like that will serve you well in other classes,
Yeah.
just not this one. But
Yeah.
this is great. Keep always put some effort in. So this is actually just a known one. It looks really complicated, but it's the integral of cosecant x cotangent x dx is minus cosecant x, because the derivative of cosecant is cosecant tangent, and so that's why this works. So this 4, if you bring that out, 4 integral pi over 4 pi over 2 cosecant x cotangent x dx. This becomes 4, but then there's this negative, so bring that negative out. cosecant x evaluated from pi over 4 to pi over 2.
Okay.
So now you have to be able to evaluate this, and this is your, your unit circle problem, where if you can at least draw something that could help here. So at pi over 2, you're up here. So you're at 0, 1. So cosecant is the reciprocal of sine. Sine at pi over 2 is the value of 1. So the reciprocal of 1 is 1. So this becomes -4 times 1.
Okay.
At pi over 4, the sine value is the square root of 2 over 2. Okay, but because it's cosecant, it's reciprocal of that, so it's 2 over the square root of 2.
Okay.
Okay, so this is 8 over the square root of 2. You would be expected to rationalize, so you get 8 root 2 over 2, which is 4 root 2. So this ends up being 4 root 2 minus 4 as your final answer.
Okay.
Litters. All right, so this one here, this one requires a rewrite step.
Yeah.
And it's a reminder that the square root of x is x to the 1/2 power. So this is the integral 4 to 1. So again, notice the bounds are backwards. I don't know why instructors emphasizing that, but you gotta deal with that at some point. And you can either make it negative now, or you can always do top minus bottom. You don't have to deal with it, but you have to acknowledge that it's there. So antiderivative of this is 9x. Adding 1 to 1/2 is 3/2 over 3/2, evaluating from 4 to 1. Okay, so when you're dividing by fractions, like multiplying by the reciprocal is 9 times 2/3. Okay, that's 6. So it's 6x to the 3/2, evaluated from 4 to 1. So it's 6 times 1 to the 3/2 minus 6 times 4 to the 3/2. As a reminder, 1 to n is always 1. So this on the left here is 6 times 1. On the right, though, you can write it 4 as 2 squared. So 2 squared, 2 times 3/2 is just becomes 3. It's 2 to the 8th. That's 8. And then so it's 6 minus 48, which is -42.
Okay. Okay.
All right. Have I sent you a table of integrals, or do you have one that you
Yeah,
like
you
to?
sent me one.
Okay. The next one is kind of straight from that list. If you look at the integral of 1 over square root 1 minus x squared dx, this is arcsine of x.
Okay.
And if you don't know that, you have no chance. So you can bring this 6 out, 6 integral 0 square root of 3 over 2, 1 over square root 1 minus x squared dx. So it looks like you're going to get a couple of these like weird ones where you got to just know the formula or you can't do it. So the antiderivative, like all of this right here, is arcsine of x, sine inverse. Bring that 6 down, and then you evaluate 0 to square root of 3 over 2. 6 sine inverse square root 3 over 2 minus 6 sine inverse of 0. So even if you can't like evaluate, like if you don't remember what angle that is, you should at least write it out this way.
Yeah.
So the arcsine is only good in the first and the fourth quadrants. So it's asking for what angle is the sine of that angle, square root of 3 over 2. So we know that that is up here at 1/2 comma square root of 3 over 2, and that's at pi over 3. So the sine of pi over 3 is square root of 3 over 2, and that's it's like asking the backwards of it. The forwards is, what is the sine of pi over 3? Square root of 3 over 2. The inverse is the backwards of it. It's saying for what angle is the sine of that angle? Square root of 3 over 2. Sine of 0 is 0 because you're right there. So, so this one actually kind of works out nice, I guess. It's just 2 pi when you're all done.
Oh, nice. Okay.
Okay. 6.
And you can skip over 7. He explained that one in class.
Okay.
If you want, but still do 6.
Okay, find the area of the shaded region. So this part of the course is like, it seems like I wouldn't have guessed you were here based on this, but you have to do the top minus bottom, meaning the function. So there's a function here between these two lines, or between these 2 points, and it's a line. So we got to figure that out. Okay, so to figure that out, the fast way is to say, oh, it's got a b value of 3, and it's got a slope of 1, 1. So it's x plus 3 is your top function. So this x plus 3 is your top function minus your bottom function, which is x cubed plus 3x squared. So the area, and this seems out of scope for what you've shown me so far, but the area is the integral from left bound to right bound, -1 to 1, top minus bottom dx.
And then we do like the 2 separate.
Yeah, I mean, you can actually combine them, do it all together. Like this just becomes x plus 3 minus 3x squared minus x cubed. So we just find the antiderivative of each of these. So it's 1/2 x squared plus 3x minus x cubed minus x to the 4th over 4, evaluated from -1 to 1.
Okay.
I don't know how you're supposed to know to do this, because this does come a little later in this course, but
yeah.
Anyway, so this is 1/2. When you put 1 in, 1 squared plus 3 times 1 minus 1 cubed minus 1 to the 4th over 4th. But then you have to subtract out the other bound. So it's 1/2 minus 1 squared plus 3 times -1 minus 1 cubed minus 1 to the 4th over 4. Okay, 1/2 plus 3. This over here, 1/2 plus 3 -1 minus 1/4. Ooh, so that's 2, 2.5, 2 1/4. That's 9/4. Minus, okay, we got 1/2 minus 3. This is -1 plus 1. This is -1/4, but then we got this negative, so it's -1/2 plus 3 minus 1 plus 1/4. All right, so those make 10/4. That's 12/4. That's 22/4. And then we got -2/4 minus 4/4. I mean, this isn't calculus at this point. This is just like adding fractions.
Yeah.
So it looks like it's just 4.
Oh, nice. Okay.
The key though is like, could you have written this equation like if it's going the other way? Could you write the equation?
Probably now.
Okay, then that's all that matters then, because you got to be able to
Top minus bottom.
Yeah, and the whole bottom's in parentheses.
Okay, and it's x plus 3 because the slope is 1.
And the b value is 3. You could do the whole y2 minus y1 over x2 minus x1 to find the slope.
Yeah.
You'll get the same value. You could go mx plus b, and at some point you want to do it a little faster, but as long as you get the right equation, you'll get the right.
And 3 is just the y-intercept.
It's the b value. Yep.
Awesome. Okay.
Okay. So that, you said the next one you already had an explanation for. So we're up to 8.
5 minutes. And then we don't have to do the bonus. I don't think we'll have time, but
yeah.
I was like, I'm done.
You should get bonus for doing a lesson with me. I know this isn't the most exciting thing in the world to talk about.
Well, it is if it helps me get a good grade on the test.
All right. All right. Well, that's good. So there's a lot of words here, but it says that G means take this X value and put it up in the top limit and find the area under the curve between those two limits. So
I plugged in the 3.
this is perfect. Yeah. So now you have to find the area from -3 to 3. So you have to find this area right here. That triangle, and then
Okay.
this triangle right here.
I got a shade in so that I can like see it with my eyes.
Yeah.
I feel like that would help me a lot.
Yeah. I kind of overdid it here, but triangle 1 is 1/2 and your base is 1, 2, 3, 4, 5. It's okay to count. And then I lost because I did all the shading. Let me get rid of some of that. 1, 2, 3, 4, 4. So your area of triangle 1 is 10.
Okay.
But then this other one, you kind of got to do a little bit to figure this out. I guess, like if you wanted to make a guess, which I probably would have as a student too, is so just it's 2, so it's 1/2, 1 times 2, but it's negative because it's below the x-axis.
Yeah.
So it's 10 minus 1, which is 9.
Okay. That's it for that one. These are a lot more simple than I thought.
Yeah.
You just gotta like know what to do, and then it's easy to plug it in.
Yeah.
Okay.
Yeah. It'd be great if you could transition to that other class. But probably can't get in there with the other teacher.
It's Calc BC.
Oh, okay.
It's not AB. We have no more. We have no AB teacher. She's a little bit special. But.
All right. So this one says to find the derivative of this. The derivative is okay. The derivative is review. So review meaning like you're going to use quotient rule because you got your top, you got your bottom.
Yeah.
So your derivative is bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared.
Okay.
So your h prime of 3 equals 5 times 3 g prime of 3 minus g of 3 times 5 over 5 times 3 all squared. So we need to go find two things. We need to find g of 3, which you just found in the previous problem.
True.
Okay. And then g prime of 3, we have to go back and do something else to find that. So is that okay so far?
Yeah.
Okay, so if we go back to what is g of x, actually, let me slip this in. See if I can get it down here. Okay. All right, so g of x is this. So g prime of x means you're going to take d dx, okay, of the integral from -3 to x f of t dt.
Yeah.
Okay, and you know from doing this that it's f of x because you just put that x in there,
Yeah.
and then you multiply by the derivative of x. Okay, but when we put a number in, okay, it's the derivative of that number. So it's f of 3, and the derivative of 3 is 0. So this whole thing becomes 0.
Okay.
Definitely would not have expected you to know that in this class. So that takes care of this first one. That one just goes to 0 now.
Okay.
And then you're just plugging in numbers. It's -9 times 5 over 15 squared, 225. So -45 over 225 is -1/9. No. 8th. I don't know. That's not right. fifth.
Hold down for a second so I can see where you got the 0 again.
It's from the fundamental theorem of calculus, but it's because when you put the top bound in, you put that in, but then you multiply by the derivative of it. The derivative of the top bound is 0. That's why the whole thing is 0.
Okay. The derivative of top bound. Okay. So if let's say if there was like a 2, so it was 2x instead of just x.
Let me go back to that question here it was on page 1, because it's the same thing you were doing on page 1 here, right here. Do you see how we put that top function in there?
Yeah. So I
Okay.
get that part.
But let's just say here, let me grab this and let me just change this slightly, because it'll make sense, I think. I hope. Okay. So let's say you're doing this. Let's say this was just like 5 down here on the bottom. Okay. So when you're taking the derivative of the integral, you take this top thing and you just plop it in there. So it's tangent 7, 5x to the 4th to the 6th, and then you multiply by the derivative of the top, right?
Yeah.
20x cubed. And you're like, I got that. Well, you actually do the same thing on the bottom. You take the bottom number, put it in here. So it's tangent 7 times 5 to the 6th. But then what's the derivative of 5?
Oh. Okay.
0.
So since -3 doesn't have a variable, it's
That's
just
right. Yeah. So like the way this is taught is there's usually a number in the bottom, but they don't tell you why it's 0. They just say it's just this first part. It's because the derivative of 5 is 0. And that's why the derivative is 0 in this previous problem we're doing, because the upper bound's derivative is 0.
Okay. Okay. And what question did you take that for? Just so I can write it down. 2.
2. Yeah.
Okay. Cool.
Well, we got through everything, I think.
Yay. Yeah.
And appreciate you scheduling. I'll send you the notes here shortly, and I'll see you next time.
Okay. Awesome. Thank you so much.
Have a great day. Bye now.
Yeah.